So we're still on page 93. Now we're looking on the bottom half of this page. And right now you'll notice that we are again still dealing with the power changing into radical. But instead of having just a 1, like we did in the previous example, there is a number or a value for the numerator. But the rule doesn't change. Remember what I said, that will stay as your exponent. And this is what that becomes your index. Okay, so here we have, they've given us just in variable form a to the power of m over n. You'll notice your a becomes your radicand, and your n becomes your index, and m becomes the exponent of it. And like I said, you can either write it inside or write it outside. So we have to judge on a question. If we're dealing with large numbers where we can take the root first, I would do the m afterwards. But sometimes if you don't have that m inside the numbers, it's not possible to take a root of it. Okay, so let's take a look at some examples and see how this works. So here is this example, part C on that page. All it really wants us to do is write it in the radical form. So remember, we have to keep remembering that this is the index here, and that is your exponent. Okay, so my base becomes my radicand, and 3 is my index. Now you could write as 5 as an exponent inside, or you could write 5 as an exponent outside, but you have to put a bracket around it. Both mean the same thing, so in this case you can switch it up. So for the next one again, b is your radicand, 5 is your index, and the 4 is your exponent. Or you could put that 4 outside, still as an exponent, but to the entire thing. Okay, last one, not the last one. And here we have p, the denominator becomes your index, but it's a 2, so we don't write a 2, it's invisible 2 there, right? So we don't really write that 2 in there, but just doing that to show you guys that that's where it will go. And then you can put the 5 outside. Okay, last one here, n becomes your index, m becomes your exponent, or you can put that exponent outside. Okay. If we look at the example on the next page, we can actually see places where we can evaluate it. So on page 94, on the warm-up exercise, which is, again, we are looking at part C of it. Here we're actually going to be able to evaluate this. So we have 64, that will become our radicand, 2 becomes our index, and then I will do the cube of it later. So remember, if I put this 3 inside, I would first have to cube my 64. It will become a big number. Then I will do a square root. So that's why I say leave this outside. So figure out what's here first. So this is simple. The square root of 64 is 8. And then it makes more sense to go ahead and put that in there as a cube of 8 afterwards. So this is easier to do. So here I can just go 8 cubed is then 512. Imagine if you had done this question, not that it would be, it's not possible to do it, because we know this is also an acceptable form to write this question. You would have to first go in and put in 64 to the power of 3, which is a big number. And then to square root that, you would then get this answer. So I think if we can just do this later, it keeps our numbers smaller. So in the next question again, I would first write that as my radicand. 2 is my index, don't need to write that. And then once I get the answer, I'll take it to the fifth root. Okay, so this becomes, the square root of 4 becomes a 2, and then to the fifth root gives me 32. Last one again. This is my radicand. Denominator becomes the index, and then everything will get cubed. So this is fourth root of 81 is 3. So first I found out what this equals to, and then to cube it, it gives me 27. Okay. Now, what if they ever give you a decimal as an exponent? Well, this is also a fraction. Okay, so remember that you can write that as a fraction itself. So if I take 1.5 to the side, it's the same as 15 over 10, which if you reduce it becomes 3 over 2. Or if you know that 1.5 is 3 over 2 directly, you can use it. So this is actually the same question as part 1, but instead they just gave you the answer as as a decimal instead of a fraction. So I could again write that as a power if I need to. It would be the same thing.